Alright, good morning. Today what we're doing is we're expanding upon the Pythagorean theorem a little bit, and you can see that there's a story problem up on the screen for you for your notes today. We're going to go over a couple different kinds of story problems. We can't go over a lot of them because there's so many different ways that you can put this into a story problem to up the complexity of it, so I can't cover a lot of them, but we're going to cover two examples and kind of get you back in the practice of pulling the pertinent information from that and then coming up with a solution to the story problem. And remember, these are all centered around the Pythagorean theorem today. So you can see that I've started to underline already some of the important information. So let's go ahead and read the actual story problem and then start to kind of pick it apart and come up with a visual representation of what this looks like. So up here we've got a utility pole is 10 meters high and supported by two guy wires. Each guy wire is anchored by 3 meters from the base of the pole. How many meters of wire are needed for the guy wires? Okay, so that's our basic problem, and I've already started, like up here, I kind of underlined the utility pole is 10 meters high. So let's go ahead and start with the utility pole. Okay, so here's our utility pole. Okay, and that is 10 meters high. So 10 meters. Okay, so the second is it's supported by two guy wires. Each guy wire is anchored 3 meters from the base. Okay, so for the distance for the base, let's go ahead and put that in green. So the distance from the base where they're anchored is going to be 3 meters. Okay. And so what they're asking is how many meters of wire needed for the guy wires. And so obviously the guy wires are going to be from the top of the pole to where they're anchored, where I put that line in blue. So blue is the guy wire. Okay, so we've got our basis of our right triangle. Remember, because the pole, assuming that it's vertical and assuming that the ground is horizontal, which we're going to do for this, that's going to form our 90-degree angle, which is our right triangle. Okay, so over here, let's go ahead and write out the Pythagorean theorem. So we have a squared plus b squared is going to equal c squared, our hypotenuse. Okay, so once we've got that far, now let's go ahead and plug in our numbers. So I'm going to try to keep these color-coded here. So a squared, that's one of the legs, so that's our 10 squared. Okay, plus b squared is the distance that was anchored from the pole, so that's the other leg, so 3 squared. And that's going to equal our hypotenuse, so that's our c squared, which we don't know yet. Okay, so let's go back, and 10 squared is going to give us 100. The 3 squared will give us the 9. And then we still have our unidentified c square hypotenuse over there. Okay, I'm just going to leave it in one color. We'll just go back to white now since we're going to start combining these. So 100 plus 9 is 109. Okay, still equal to c squared. Okay, now to get the c by itself, it has that square, and so that's where we get into using the square root, so we can cancel those two. Okay, and we have to square root this side also then to keep the equation balanced. So we're left with just c over here. Now what I'm going to do is, because that's going to come out to be a decimal, because 109, the square root, is not a perfect square, so when we do this, I'm going to go to the nearest tenth. And so if you put 109 in there and get the square root of it, what you're going to get is 10, and we're going to round that to 10.4, so again to the nearest tenth. And I already made a mistake here, because 10.4 is not the perfect square, it's only an approximate, so that should be a wavy equal sign. Okay, so approximately. So that's the length of, we'll go back to blue, so we'll say that that is 10.4. Now this does say that there are two of them though. Okay, so we need to multiply 2 times 10.4. No. So that's going to give us, what, 28.8. Okay, so the length we need for both of them is 20.8, in this case meters. Okay, so you can see how we took the pertinent information from the story problem. Then we drew our picture so that we could see what our right triangle looked like, and we can see what lengths we had. In this case, we had the two lengths of the legs of it, but it doesn't necessarily have to be that way. And we'll look at another problem that is a little bit different in the next one. So, okay, so that's your first example, and give me just a minute and we'll come up with your second one.